Third graders, today we're going to solve area problems using the strategy Find a Pattern. Please read the story problem. Mr. Hoy wants to build storage buildings, so he drew plans for the buildings. He wants to know how the areas of the buildings are related. How will the areas of building A and B change? How will the areas of building C and D change? Use the graphic organizer to help you solve the problem. Okay, number one, our first box says, what do I need to find? Read the stuff in it.
I need to find how the areas
will change from A to B and from C to D. What goes in these?
C to D.
C to D. Write that in. Okay, what information will we use? I need to use the blank and blank of each building to find its area. What are you going to use? How do you find area?
Counting the blocks.
Okay, by counting the blocks or doing multiplication and divisions. But you could do the length and the widths, right? Which a lot of times you were doing that with perimeter too. But you're going to use the lengths and the widths.
Do we put the initials?
No. You're going to have to write outside the line like I did. Length, length. The reason why we can use length and width right now is because they are showing you that 3 rows is the outside length. And then 4 in each row is the width. Okay? So they're showing you can see that on all of them. There's 3 and then 8, 6 and then 4, 6 and then 8. Does that make sense? So you can use the length and the widths to find area this time. Okay? I will record the areas in the table. Then I will look for a pattern to see how the blank will change. What are we trying to see what that changes? Areas. To see how the areas will change. Okay, so let's solve this problem. We're going to complete the table to find the patterns. Okay, building A has a length of 3 feet. What's the width of building A?
4 feet.
4 feet.
4 feet.
Make sure you have your label. Okay. Now, what's 3 feet and 4? I don't say 3 and 4. But when we're doing area, what are we doing in a rectangle? What can we do?
Put the blocks inside.
But how do we find it? How can we find area? Multiplication. So, we have 3 and 4. So that means the area is 12 feet. Because 3 times 4 is 12. Right, Alexander?
Yes.
Okay, let's go to building B. Building B is 3 feet tall. But how many feet wide is it, guys?
8.
8 feet wide. Write that in. Now if we're using multiplication, what is 3 times 8 to find the area? What is 3 times 8?
24.
Alright, let's go to building C. Building C, this time they didn't give you the length, they gave you the width. So let's do building C. Length is what?
6
6 feet. And the width is 4.
Oh.
What is 6 times 4? Everyone?
24.
Thank you for waiting on me to ask for people before you shouted it out. And now let's do building Z. We have, what is our length? 6 feet. And then they have 8 feet. What is 6 times 8? Think about it for a minute. 6 times 8. Okay, what is it?
48.
48 feet. You see how knowing your multiplication problems are going to make area easier sometimes? Okay. I see the lengths will be the same and the widths will be doubled. Look, on building A and building B. The lengths are the same, right? 3 and 3. The width is doubled. If you double 4, what do you get? Right, Tedman?
Oh
You double 4, what do you get?
8.
8. Okay. So the areas will change from 12 to 24.
That's just a 12 plus 12.
Right. So 12 to 24.
And 24 to 40.
And from 24 to 48. So when the lengths are the same and the widths are doubled, the areas will be doubled. Because you said 12 and 12 is 24, right?
And 24 is 48.
Yes, 24 and 24 is 48. So they will be doubled.
You even told us that.
Well, I was reading in the story. So I didn't tell you that. The paper did. Okay, but let's wait. Hold on. I know you guys are done. But let's think about this. If the lengths are the same, the length's the same here, the lengths are the same over here, right?
Yeah.
So that's a pattern. Then the widths double, and the widths double here, right?
Yeah.
So then the area doubles. And the area doubles here too. So if the lengths stay the same, but the widths double, the area doubles. Okay. Let's try another problem. Read the story. Mr. Coy is building more storage buildings. He wants to know how the areas of the buildings are related. How will the areas of the building E and F change? How will areas of buildings G and H change? Use the graphic organizer to help you solve the problem. Okay, what do we need to find? Brendan?
How will the areas of buildings G and H change?
That's one of them. You didn't say both of them.
How will the areas of buildings E and F change?
Okay.
2.
Oh, yes. So how will the areas of E and F change and G and H change. What information do I need to use? We're gonna, we looked at the previous page. It says I need to use
the length and width of each building to find its area.
Okay, I'm just gonna say the length and width of each building to find the area. We're going to write the exact same thing that we had on the previous page. I will record the areas in a table, and I will look for the pattern to see how the areas change for the third box. Okay, once again.
I'm not done.
No, I'm not talking. It's okay. I'm talking to the recording.
Oh.
I will record the areas in a table, and I will look for a pattern to see how the areas will change. You can write that in print to make sure you get it all. Let's figure these out. Building E, what's the length, guys?
Building
5 feet. Okay, 5 feet. You can write FT in print right now if you want. What's the width for building E?
8 feet.
Okay, now you need to do your multiplication. 5 times 8.
45. 45. 45. 40.
All right, building F, length.
5 feet.
5 feet. What is the width?
4.
Okay, what's 5 times 4?
20 feet.
All right. Building G. What's the length?
10 feet.
Okay, before I start, building E, what's a pattern that you see? Can I get? No, I want the other. Start with length. What's the pattern for length?
4.
The lengths are
The same.
the same. What's the pattern for width?
4 plus 4 equals 8.
Okay, but it goes from 8 to 4.
It's subtraction.
It's not subtraction.
It's taking away half.
It's halved. Thank you. Yes, it's halved. It's split in half. So to go from 8 to 4, it's split in half, which then makes the areas split in half. Okay. Now, width of building G.
8 feet.
Okay, what's 10 times 8?
80 feet.
All right. Now, what's building H's length?
10.
10 feet. What is building H's width?
4. 4.
4 feet. What is 10 times 4?
40.
Okay.
It's half again.
It's half again. So if the lengths are the same and the widths are halved, then the area will we have? We need to write that down, those words.